So in this video I'm going to discuss Codeforces round 953 rated for division 2. So I will be solving first 4 problems in this problem set. So let's start with problem number A, that is allies and books. So in this question allies has n books and first book contains AI page, second book contains A2 page, and similarly nth book contains AN pages. And allies does the following. What she does, she divides all the books into two non-empty piles. Thus, each books end up in exactly one of the two piles. Okay, and Alice reads one book with the highest number in each pile, and here highest number means the highest index, right? Okay, so what is the maximum number of pages which Alice can read? So this question is very much easy. Like it is problem number A only. So what you can do similarly, like for each and every index, just try to compare the maximum index from this index with the last index. Okay, because last index is compulsory, it will always be included, right? But what you can do in a, you can send all this, for example, let me take a case, like is this and this is giving you maximum, just a hypothetical case, this number and this number is giving you maximum. Then what you can do, you can simply send all this number into one pile and all this number into one pile. Then maximum could be this of one pile and this could be another of another pile. So that's how you can solve the problem. Let me show the code. The code is also easy. So answer is maximum of a of I plus a of n minus 1, and the maximum of all this possible combination will be your final answer. So that's how you can solve the problem B. So let's now discuss the problem number A. So let's now discuss the problem number B, that is new bakery. So so Bob has decided to open a bakery, right? And what he can do, he has total n buns or whatever you can say, n units of thing something. And what he can do, he can simply sell each bun in a price of a coins. Okay, but what he has done, he has launched a new scheme. And what is the scheme? He will choose a integer k which is a minimum of n comma b. Okay, b is given to you in the question only, so don't worry about it. So Bob will choose a number k which could be minimum of n comma b. And what he do, he sell first k buns at a modified price. And what is that modified price? The modified price is b minus I plus 1, which means if you are selling the first bun, then price of that one would be b. Then price of second bun would be b minus 1. Price of third bun would be b minus 2, till this process will be continued till the k. Okay, and rest of the buns would be sell at the price of a coins. Okay, now Bob want to get the maximum profit. Now you have to tell them what is the maximum profit Bob can attain. So the maximum profit simply decides on the factor what k you are choosing. Okay, so you cannot brute force all of the case, because k is 10 to the power 9, you cannot iterate in that portion. So you have to think something else. So what is that case? So let me tell you the case. So if you are given like that, if your a is greater than or equal to b, which means like what is the maximum one value you can what is the maximum value of one you can sell if you're choosing some k greater than equal to 1. Okay, then that could be b only. Okay, so that is the greatest price of one which you can sell if you're choosing k greater than equal to 1. But if that number is, if my a is already greater than or equal to that number, then it is always beneficial to sell all of the ones at the price of a units only, which means in that case answer would be n into a. Okay, clearly it is the answer. But if it's not the case, which means if your a is smaller than b, then what could be the price? Then what you can see, like there's one thing to observe, that what is the sequence of the what is the sequence of selling the ones. If you're choosing some k greater than equal to 1, then your first one would be sell at b, second one would be sell at a price of b minus 1, third one would be sell at a price of 3 b minus 2, and similarly b minus 3, and similarly b minus 4. Okay, now there must be a position, like there must be a place where your this b value is becoming smaller than or equal to a. So let's suppose this is b minus, let's suppose 7. Okay, I'm taking a hypothetical case. Let your b minus 7 is smaller than your a. Then at this place you will stop. At this place you will stop, which means till b minus 6, your b minus 6 is greater than a, and your b minus 7 is smaller than a, which means it can be equal to also, like whatever. So what you will do, you will sell first 6 buns at a price of you will sell first 6 buns at b price, which means according to this equation, b minus I plus 1, and rest of the buns with the equation, rest of the buns at the price of a only. Now how to find this number? you can easily find this number. But how? This is simply b minus a. Okay, if your let's suppose b minus a is equal to index. Okay, okay, if your b minus a is equal to index, then what you will do, you will sell first IND, you will sell first IND number of buns at a price of b at using this equation only. Because what is a minimum value of bun which could be sell if you are using k is equal to index, that is b minus index, right? And we have proved that this number is already greater than or equal to a. Okay, you will stop at this position, and rest of the numbers would be sell at a price of a only. Okay, similarly the rest number would be n minus index, and this would be multiplied by a. So that is your whole answer. But how to find this equation? Like, but how to find this equation? This is also easy. Like, what you have to do, you are selling 1 to index number at a price using this equation, right? Using this equation, that is b, and rest of the numbers from IND plus 1 till n at a price of a. You can simply find that because this is n minus index into a. Okay, you can find this. But how to find this? So this is also easy. Let's suppose you are k, you are choosing a k is equal to index, right? This is proved here. You are choosing k is equal to index here. Then that number of time you are already adding b in your equation. Then that would be b into current k, or that can be index also. This can be index also. This one and only the same thing. B minus k, and you are subtracting a sum. But you are subtracting a sum. What is that sum? Simply according to this equation would be 1, minus 1, minus 2, minus 3 till minus index. Okay, you can find the sum of all these number together. But how? Using permutation and using combinatorics, that is index. Oh, I can write it k plus 1 divided by 2. Okay, you can find the sum, and this would be subtracted. And what is end? That is end is plus 1. How many times this 1 would be added? That is k times only. That is k here. Now this plus, what is the next? Next is simply n minus index, that is n minus, I can write k also, n minus k into a. So you can find this answer easily. And what is this k? How to find this k? This k is b minus a. If your b is greater than a, if your b is not greater than a, then answer is simply n into a. If your b is greater than a, then find the k according to this equation b minus a, and just using this equation find the answer. The code is also easy. The has a respective code. What I am doing, if my a is greater than b, then answer is n into a. Else what I am doing, I am finding the difference. What is the difference? Difference is a minimum of, no, there is also a case. फोन कर दे. Sorry. So there's also a case like that. If your b minus a, there's also a case if your b minus a is greater than n. In that case, but you will always choose a greater k, because in that case you will get a negative answer. So just write a condition of minimum of n comma b minus a, right? And what is the sum? This sum is simply the sum. That's b into k. That is b into difference, right? And but what will be subtracted? K into k plus 1 divided by 2. I'm subtracting k into k plus 1 divided by 2, and simply adding k, right? Okay, now now find the answer. Now what will be your answer? N minus difference, that is the remaining part into a, remaining part into a. So that's how you can solve the problem number b also. So let's now discuss the problem number c, that is Manhattan permutation. So this was a very much interesting problem. I guess it is much harder than D problem. Okay. So in this question, you have to find a permutation. Okay, let me tell you here. Like you have to hope so you know what is a permutation is. So you have to find a permutation such that uh, value of p1 minus 1 absolute value plus p2 minus 2 absolute value plus p3 minus an absolute value plus adding all of this number, adding all of this number, you will get a sum of k. What is k? K is given to you, and this is size of permutation. So this question, I think so it is much more about greedily problem, I could say. Yes, it is more about greedy. Okay, so first of all, try to find what is the no case. In the case in which you cannot find the answer. So what you can do, you can simply find the maximum sum which is which you can get. How you can get the maximum sum? By reversing the array, which means like one. So I'm telling you 1 2 3 4 5 6 7. Okay, now it will be 7 6 5 4 3 2 1. Okay, so if you are writing equation like this, this is the this is the part which you have to subtract from each and every dex. This will be constant. So if you reverse your permutation, it will generate your maximum sum. If your given k is greater than this maximum sum, then your answer is straight no. Then you cannot find your answer. Okay, so that is a condition in which you cannot find the answer. So but if it is smaller than k, then how you can find the answer? Like there's also a pretty much good observation in this question which you have to do without for solving this problem. And what is that observation? Like let me tell you. Okay, so if you swap any two numbers, let me now write the original array first. In with respect to original array, I'm saying like that. Like this is my original array 3, 4, 5, 6, 7. Now 1, 2, 3, 4, 5, 6, 7. Okay, if this is my original array, right? This is my original array. If you swap any two numbers, let me swap these two numbers. If you swap any two numbers, if you swap any two numbers, at at what pace your answer will be increased. So this is a very good observation. So this will depend on the distance between them. So let's suppose you're swapping 3 and 6. My 6 would be here and my 3 would be here. Now what is my increased number? My increased value, I can say. So the difference between 3 and 6 is now C. Difference between 3 and 6 is now 3. That is overall my how much value is increased. My overall value is increased by 6. And what is this 6? What is this 6? This 6 is simply distance between these two indexes multiplied by 2. Okay, so how to find this? So I am swapping 3 and 6, right? I am swapping 3 and 6. So what is the index difference between 3 and 6? That is 3 only. Okay, 3 only. Now multiply these 3 with 2, and this is the effective increase in your answer. So tell you another. Let me try to give you example to another test case. If you are swapping, let's suppose this and 5 and this, so what is the expected increase? Expected increase is, oh, so it is again 3. So let me take these two indexes. So what is expected increase? Expected increase is 8. But why? Difference between 2 and 6 is 4. 4 into 2 is 8. 4 into 2 is 8. Yes. So let me give you example also. That I'm writing 6 here, I'm writing 2 here. Now 6 minus 2 is 4. Now 6 minus 2 is 4. 4 plus 4 is 8. Okay, now keep this in mind. Like if you swap any two indexes, then increased value would be distance between them multiplied by 2. So that is a whole agenda of this problem. Whole problem, like a whole trick of this problem, I can say. But how to solve this problem now? Now this is again a good question. So keep this in mind. I'm making it here. Okay. Now what is the maximum increase you can get? What is the maximum increase you can get? That is simply if you swap last two numbers, first and last number. So let me tell you why. If you swap this and this, if you swap 7 and 1, if you swap 7 and 1, that is a maximum. That is the maximum increase you can get. Yes, that is a maximum increase I can get. But so what is that value? That is simply n, that is simply 2 into n minus 2. Yes, it is this only, because 1 minus distance between 1 and 7 is 6. Yes, and distance between 1 and 7 is 6, and 6 into 6 is 12, and similarly it equals to 12 only, because my n is 7, and uh, 7 into 2 minus 2 is 12 only, which means the maximum increase you can get is of 2 into n minus 2. Okay, so this is the maximum increase which you can get, right? Okay, done. But how to solve next? So you can, now what you can do, you can simply now run a greedy approach. Oh, two pointer approach, it is also greedy only. So what you will do, so let me try to debug one test case, that is, I guess, this only, or some, I can take some complex. mm, this is what test case is, 1 2 3 4 5. Okay, now let me take this test case. Okay. Okay, so let me get you here. Okay, great. So what is my test case is 8 comma 14. So first of all, write your equation slowly, like 1 2 3 4 5 6 7 and 8. Okay, now what is your current maximum value? Now your current maximum value which you can increase is 16 minus 2, that is 14. Yes, 16 minus 2 is 14. Great. Now your first pointer is this place. Okay, now your second pointer is this place. and you are having your current maximum value as 14, and you know that the maximum the answer you have achieved is also 0, which means the answer. So what is your current answer? So let me, like, you will get it more understandable. This is like 3, 4, 5, 6, 7, 8. Now what is your current answer? Your current answer is 0, right? And your pointer are, one pointer is on this index, another pointer is on this index, and your current maximum achievable value is 14. Okay, how is this 14? I tell you in earlier part. If you swap this index with this index, you will get a 14 answer, and your required answer is also 14. Now what you will do? You will simply swap these two numbers. That is 1 with 8, and you will write 8 here, and you will write 1 here. What is the increase? The increase is simple 7. The increase is simply 7. 7 plus 7 is equal to 14. And you got your answer. Yes, this is how simple the problem is. So let me try to do another test case. Let it be. mm, let's now try to debug this test case. What is the test case? 5 comma 2. Okay, and that is 5 comma 2. Now I will write the equation 1 2 3 4 5, and write it 1 2 3 4 5. Okay, I have written the equation. Now what I will do, what is the maximum achievable value current now? The maximum achievable value currently is 2 into 5 minus 2, that is 8. I can achieve a maximum value is 8, and my current pointer is on this index, my next pointer is on this index. And you know one thing, that what is your current answer? My current answer is also 0. Now you one thing, your maximum achievable value which you can achieve on this index is somehow greater than your required value. Then what you will do, you will simply increase this pointer. Okay, I have increased the pointer. Now you will notice one thing, you cannot achieve it. I cannot achieve 8 now. So we will decrease the 8 by 2. Okay, so so we will decrease the 8 by 2, because by increasing one index, your difference is also been decreased, right? Your difference is also been decreased. And what is your current maximum achievable value? That is 6. Now you know one thing. 6 is also greater than 2, which means I do not need to swap 2 and 5. Okay, now move to the next index. Now 3. Now you also know one thing. Now your indexes are shorter. Indexes has shortened, and then your maximum achievable value has also been decreased by 2, because increasing one index will decrease the difference between them by 2. So it is now 4. So similarly 4 is 4 achievable? No, 4 is also not achievable. So move the pointer to this index. Now maximum achievable value is 2. Yes, maximum achievable value is 2 now. So what you will do, and your required value is also 2. You will simply swap 4 and 5. Swapping 4 and 5, adding 1 here, adding 1 here, and sum of these two numbers is 2 already, and you will got your answer. So that is how your problem simple is. Okay, hope so you got the got the idea how you can solve the problem. I think so. There is no more good test case in this. So let me generate my test case. So I'm writing a equation like 7 and getting, I want to achieve a sum of let's suppose 8. Okay, I want to achieve a sum of 8. Now my 1 2 3 4 5 6 7 8. Okay, now 1 2 3 4 5 6 7 8. Now your current maximum achievable value, that is 7, 2 into 7 minus 2, that is 12. Okay, now your current answer is 0. Okay, yes. Your first pointer is at this index. Okay, my another pointer is at this index. Great. Now, is your maximum achievable value greater than your required value? Yes. Then what you will do? You will simply decrease the pointer. Okay, decreasing the pointer will also decrease the value, that is now current is 10. Is your 10 required? No, 10 is also not required. Simply decrease it also. Simply decrease it now. I have decreased it. Is your 10? Oh, so 10 is also will decrease to 8. Now you will see 8 is that number which you want. So simply swap these two numbers. That is 8 with 3. Okay. So 8 with 3. Now 3 minus 8, that is 5, I guess. No? Oh, I guess there's okay. My maximum achievable value was 14 from the start, because my n is 8. Okay, hope so you got the point which I'm telling you. So let me just wait a minute now. Okay, my current answer is, what is this? My current answer is 0, and my maximum achievable value was not 12. It was because my n is okay. What I have done, great. I've got the point. So let me just remove these two numbers. Uh, so now it is just 12 only, because 2 into 14 minus 2 is 12. Okay, now your first pointer has this index, your last pointer has this index. Now is your maximum achievable value greater than your required value? Yes, simply decrease the pointer. Now what is your next value? That is 10. Oh, so cut it. Now your 10 is greater than 8. Yes, simply decrease it. Okay, I am at this index. Now what is your next achievable value? That is 8. Okay, is your 8 required? Yes, it is required. Then what you will do? You will simply swap 7 and 3. Okay, 7 minus 3 is 4, and 7 minus 3 absolute value is 4. 4 plus 4 is 8. Now that is the value which you want. So that's how to solve the problem number C. So let me show the code. The code is also easy. First of all, take the maximum. First of all, find the maximum absolute difference which you can get. If your required score is greater than answer, then simply return. Simply print no and return. Else, what you will do? This is my maximum achievable value, but I'm writing it here. That is 2 into n minus 2, right? If your maximum achievable value is smaller than your current required value, if your maximum achievable value is smaller than your required value, that is the case, your 8 you want and 8 is here also, then what you will do, you will simply add that value and simply, oh, so what I'm doing, I'm subtracting 4 from here. In other case I'm subtracting equal to, but you got the reason for this, because if I'm swapping these two numbers, both the pointers will move one step ahead and will move one step before. So I'm now changing index by two variables. In that case my minimum index would be decreased by 4. Hope you get the point. Okay, decrease the pointer by 4 and swap the numbers I plus plus j minus minus. Else simply what you will do, simply increase the last pointer, first pointer to, you can also do one thing, you can simply decrease the last pointer also. This one or the same thing, this will work also. Okay, so simply print the answer and get your AC, abstracted answer. So let's now discuss the problem D, that is elections. This problem are easier than C, I hope so. So what is the question saying to you? There are a total n candidates in an equation, in an election. An AI candidate has total AI voters for him. Okay. Additionally, there are some dumb peoples. I would say C purpose are dumb peoples. Additionally, there are some dumb peoples who have undecided their favorite candidate, and they will vote the candidate with the lowest number. And the lowest number does not mean the lowest number of hands. Lowest number means the lowest index. That is the zeroth index. Okay. Now, what is the question asking you to do? The question is simply asking, if you want ith candidate to win, then okay. So also let me complete the question. What you can do? You can simply exclude one candidate. Okay. If you exclude the ith candidate, the all of the fans of that ith candidate will become the dumb people only, which means at then they will vote the candidate with the lowest index. Okay. Now what you have to do, you have to find the number of people you can exclude, so that the ith candidate will win. Okay, hope so problem statement is clear to you. But how to solve this problem? So if I tell you like that, let me take a random test case. mm, Let me take this only. Okay, let me take this only. Okay, now you know one thing is that these are the dumb peoples. Okay, my dumb peoples are here 5. Okay, okay, oh, great. Now you will notice one thing, that that your answer can be, so let me tell you one thing. Your answer can be either be 0, either be the index which he is on, or either be index plus 1. Okay, your answer can be this only. So let me tell you each and every case. So for 0 case, when your answer is 0, when your answer is 0, the answer will be 0. For example, I'm taking a test case like this. I'm making another test case that would be 3 7 uh, 2 7 6 5, and let it be 1, let it be 6. So only one people can win with zero exclusion. That is the person with the maximum number of votes. Yes, because maximum number of votes with a lower index. Because there is a condition. If the two people are getting the same number of votes, then the person with the lower index will win the elections. Right. So also there's a case. But what is that case? You will check if your this number, that is zeroth position. If your person at zeroth position plus C. that is plus the dumb peoples, plus dumb peoples is smaller than is smaller than uh, is smaller than your maximum index with the minimum index. Okay, let me repeat it again. If your zeroth index plus the dumb peoples, that is this is the dumb people, if your zeroth index plus dumb people is smaller than your maximum index with the smallest index is that number, then you will simply print, then answer for that case is 0. Because if you're considering this test case, because if you're considering this test case, for this it will not work because it is not a lower index. Okay, hope you got my point. Now I will tell you the case in which your answer is I minus 1 I. Okay, now case for I. Now if you consider this array only, now if you want this candidate to win, if you want this candidate to win, what you can do, you can simply exclude this one and this one. Okay, by excluding this one, what this person will get after excluding these two persons, these two voters will become dumb people, right? My total number of dumb people would be 6 plus 1, right? And also the C, which is also this D, which already with me, that is already present dumb people, already dumb. Okay, AD is already dumb. So all these votes would be sent to this person. Okay, all these votes would be sent to this person. Okay, right? So if this, okay, of if this equation plus the current fan, if the plus the current fan which the persons have is greater than the maximum among them, maximum among all the indexes which are add of them, then answer is I. Okay, because what you will do, you will simply remove all the numbers, you will simply exclude all the people which are before it. But it will do, it will what it will do, it will just send all of the votes of these many people to this people, this number, because by excluding these two peoples, my minimum index would be this only, and the dumb people are voting to the minimum index, and this is my new minimum index. So all of the votes would be given to this index plus already dumb people which are already dumb. Okay, now if my this equation plus the number of fans which the persons have is greater than the maximum index, is greater than the maximum vote which person get in the next in the right part of the array, then your answer is I. If it is not the greater, so let me take the case like this. So let me take a case like this, that is 1 1 3 7 2 7 6 5. Great. And your, okay, it is here. And your already dumb people are, and what are my already dumb people? And let's suppose your already dumb people are 2 only. Okay, great. Now now if you want this person to win, if you want this person to win, you will exclude these two people. Okay, by excluding these two people, the votes will be given to this. The total number of votes the person would have will be 1 plus already dumb people are 2 plus 3. What is this? This is 2 plus 2 4 plus 7. Okay, let it be 1. Okay, sorry, let it be 1. So already dumb people are 1 only. Okay, my already dumb people are now 1 only. Okay, now what is this sum? The sum is 6, which means at the end, my this index would get the sum of 6, right? But this 6 is not greater than 7. Okay, okay, let me tell you. Okay, so if you exclude these two people, then this person would get a 6 votes. Okay, but he will not win, but he will not won after that also. But why? Because here is 7. 7 will get the maximum votes. So in that case, what you will do, if by excluding previous people, if you're not able to win, then only, if you by excluding previous people, if you're not able to win in that case only, but in that case also, what you will do, you will simply remove the maximum index from the next part, and which means by removing any of the numbers that would, any of the maximum number, I'm removing 7, excluding 7, then all of the 7 votes would be get to this only. Now he can win any of this situation, because I'm removing the maximum number, and none of the number is greater than maximum. Okay, hope so you get the intuition of the intuition of this problem. So let me repeat it again. To win the, to get the ith candidate to win, to let the ith candidate to win, one case is like that, you will exclude all of the previous people plus all the previous people plus number of fans which person have plus all the dumb people. If that, if that sum is not greater than the maximum index, then what you will do, you will simply exclude the maximum index also and add the number in this only. In that case your answer would be I plus 1. But if your this sum is already greater than your maximum index, then answer is I only. Hope so you got the point. So that's how you can solve problem C, problem number D. So let me show the code. The code is also easy. What I will do, First of all, what I will do for the first index, I am calculating answer the first index. If my first index plus c is greater than or equal to my maximum index, then answer is 0, because for the first index it is already greater than my maximum index. But listen, but see carefully. I am adding the already done people. If my lowest number plus already done people are greater than my maximum index, then answer is 0 for that number. Else answer is 1. Why 1? Because I will simply exclude the maximum number from the right part of the array, and that maximum number would be added to my 0th index only. Okay, great. Now move to the next part of the array. Okay, my move. So remember this function, that is first maximum, because so remember uh, remember for this index, that is maximum index. Okay, okay, great. Now remember for this number, that is I am maintaining a array which is a maximum sum till the ith position from the right part of the array, because that is because, for example, if I'm calculating this index, how should I know what is the maximum among these two numbers? Okay, how should I, if I'm calculating this index, how should I know the maximum among these indexes? So the maximum among these indexes would be in this array, right? Okay, great. This is maximum check, but this is the uh, I could say the max element array from the previous check. Okay, great. If my current number plus now I'm checking for the each and every index. If my current number plus lowest number plus my so it is a case in which my current number is maximum number, and that is the first occurrence of that maximum number, then answer is 0, because for the first occurrence of the maximum number, my answer is already 0. I have discussed it earlier, right. uh, okay, this is not the case. Like for the 7, like the occurrence of this 7 is first, and plus this number is already greater than my lower number plus c. If this let me repeat it again. For this index is the lowest occurrence of my maximum number. If this index is greater than my lowest number plus c, then the answer for this case will be 0, right? Yes, it is clear. Then simply put it 0 and make the first maximum as 0. Else, if your current number, if your current index, I'm taking this index, if your current index plus sum of previous number plus sum of previous number plus already done people plus already done people, if your this sum is greater than among is greater than the maximum among these numbers, greater than the maximum among these numbers, then answer for this index is I. Else answer for that index would be I plus 1, because in that case what you will do, you will simply exclude the maximum number from the right part of the array, and that part would be added in the current index only. So simply print the answer, and that's how you can solve the problem. D also, if you had doubts in any of these four problems, please comment me down. Until then, stay tuned for the next one. And please don't forget to subscribe, share my channel, my ID, and everything. And please don't forget to connect to my LinkedIn and follow me on Instagram. Thank you.